So yesterday we went over the mean and the median, right? And we did problems, these two problems right here, the warm-ups. Okay, how did we find the mean? That's right, it's the average. We add them all up, and we got the mean, and then we divide by the number of data points. Right. And we got a mean of 2.1. Did it by yourself, right? And we median 1.25, right? And that's all I told you to do, right? We only had those two problems. Okay, so we got to go on. So the mean is the sum of values divided by the number of data points. The median is the middle value. We remember how to find the median? It's exactly in the middle of our data points. Okay. You should know that the mode means the data point that occurs most. Okay, we're not going to use the mode that much in this course, but you can have multiple modes. Okay, if you have you have a set of data points and you only have one number that repeats, so you could have multiple. Say it repeats twice, maybe you have two numbers that repeat twice, so you could have two modes, or you could have no modes. Okay? Like I think in our example, we didn't have anything that repeats in this one, right? So this one doesn't have a mode. Okay. All right. A little bit about our box and whisker plots that we did last project. Q1, that was our first quartile, right? That was the median of the lower half. Remember we made a box and whisker where we found the median? Then we had to find the median of each half. When we found the median of each half, that was our first quartile. Okay. And then that second quartile, or Q2, that was the first median we found, right? So continuous probability, I don't want to get too much into what a continuous means, but you should know that the probability distribution, which now we're going to be talking about this bell curve, right? It has an infinite number of possibilities. Why does it have an infinite number of possibilities? Looking at the picture here. Well, because it comes close to our x-axis, but it never crosses it. Okay? So it does have an infinite number of possibilities. Yep. All right, so number of possibilities were the values that can be represented by an interval on a number line. Okay. And of course, I kind of gave you the hint on this one. What's the most important type of the continuous probability? It's that normal distribution. Okay. This is called the normal distribution. All right. Okay, now looking at this bell curve graph, This line here, in algebra 2, what is this line? On a parabola, what is this line? It is a maximum point here, but I'm looking for the whole line. What did we call that? Axis of symmetry, right? Okay. So this is actually, this line is our mean, median, and mode. Okay. So they're all at this point equal. Fine. Okay. We call it a bell-shaped graph. Also, it's, I think I gave this one away too, symmetric. Yeah, bell curve. Yeah, that's, bell curve is fine too. You got bell curve on there, that's fine. It's symmetric. Okay, now, this area under the bell curve. Okay, see how we have 34.1, 30, all this area is equal to the R 100%. Okay, so it's all equal to 1. Because, or 100%, however you want to think about it. The area here is all equal to 100% or 1. Okay. Of course, I talked about the normal curve, this bell curve never touches, never crosses or touches the x-axis. Okay, so the point where the curve changes from curving upward to curving downward. So here it's curving up, from here to here it's curving up, from here to here these are called inflection points. Okay, so these are inflection points. Um, we're not going to do density functions. Okay, so you can cross that out. You are my density. Remember Back to the Future? You are my density. Instead of destiny, density. Okay, how does the mean affect the shape of a normal distribution? And I gave this away too. What did I tell you about the mean? What kind of line is it? Yeah, it's a line of symmetry. Um, you might have to go back to first or kindergarten or something. When did they start reading these days? First grade? I can get you a pass to go visit a first grade and you can learn how to read. Well, then say I need glasses. Don't say I don't know how to read. I need glasses too. That's what I should do today. Okay, now think about this. How does the standard deviation affect the shape of our normal distribution? Okay, now think about what the standard deviation measures. And I told you this many, many times. It's the spread, right? It's the spread of our curve. So what's it going to affect? There's a picture of it right here. It's going to mess with the graph. Good answer. How? The lower the deviation, did you say higher the peak? So let's do it this way. The bigger, we're going to say the same thing, but I'm going to use bigger. So the bigger the standard deviation, the wider it gets, right? The wider the curve. And this is all just a visual example of it. Okay. The standard deviation here is 1 because from this mean, which happens to be 2, right? Mean is 2. And the first inflection point here is 1 unit. So this curve, this normal distribution here, has a standard deviation of 1 from 2 to 3, 1 unit. Very important here because this can get confusing. Here, my mean is 2, same as the mean here, right? But my inflection point is right here. So my standard deviation is 0.25. So the bigger the standard deviation, the wider the curve. Or, as Artem said it, the smaller the deviation, the narrower the curve. Are you lost? Okay. All right. So let's look at this little example here. Assume the scaled grades for a biology course are normally distributed. So this distribution is a normal bell curve. The normal curve below represents this distribution. What is the mean course grade here? What is our mean? Yes. Okay. This is our mean, 71. Now, I'm not going to make you use a formula yet, but you should be able to kind of estimate where the standard deviation is, right? Where's our inflection points here? Going down, going down, going down. Oops, probably somewhere around there. So what's our first standard deviation here? 76, which is how many units from 71? 5. So our standard deviation, which we're using, I forgot what that letter's called in Greek. Standard deviation is 5. 5 units from 71. Okay. Now, I actually told you guys a couple of times what the normal distribution is, kind of like the parent function when you were in Algebra 2. The normal distribution's the parent distribution of problems. Okay? It has a mean of 0 and a standard deviation, like we can really fit that on the line here. What do you think the standard deviation is going to be? Okay, if I have this normal here and say my mean is 0, yeah, it's going to be 1. So it has a standard deviation of 1. Now, the scale is going to, now statistics goes a lot into these z-scores. We're not gonna hit that up. At least I don't think so. So that's where we're gonna stop. Nope. Huh? No, the z-score. You need it. You need a book. We're almost done. We're almost done. Say it one more time. Oh, is that what you said? Now, wait. Let's go back to your other pretty colored one. Okay? Yes. Because we need to find the standard deviation. Now, hopefully this will start making sense, and hopefully I got enough time to do this. Remember I told you the formula for standard deviation? And you guys just didn't like it at all? It was the summation of x of I to n times x of I minus the mean squared, and you had to take the square root of that. Remember that? Well, that's what we're doing here. And I told you to use a chart. Well, there's no other way to figure this out until I tell you the shortcut, which I'm not going to do for quite a while. So, you guys do a little homework tonight. Find the standard deviation if you can. Remember using the chart. Okay? Yeah, that's not going to happen.